If you'd like to get a different answer for a formula or a function in Excel, and you would like to be able to control the variation of a number of other cells that control that formula, you want to be considering the feature called Solver. We're looking at the Solver worksheet. This feature is actually an extension of or an optimization of the goal seek capability. We want a different answer here. We want this to be 265,000 in cell E14. The formulas in this worksheet and they're in columns C and D as well as E essentially build off of what's happening in column B. To activate Solver, you need to first make sure that this feature is added into your Excel capability. If you go to the Data tab, if your version of Excel has already added this feature in, you'll see the word Solver in the Analysis group, just to the right of the Outline group. If you're not seeing this group or not seeing Solver, you'll need to take the following step. It only takes a few seconds and you need only to do it once. Go to the File tab in the ribbon, choose Options and in the list of choices here in the Excel Options dialog box, down the left-hand side, choose Add-ins. And then in the list of add-ins choose Solver add-in and then, at the bottom of the screen here, Manage Excel Add-ins, click Go. And here we see a list of add-ins. Solver on my screen is already checked since I already have it installed. In your case, if it's not there, you will want to check the box for Solver and then click OK. And within a few seconds you will have activated the add-in. And then on the Data tab you will see Solver. The pop-up description says, what if analysis tool that find the optimal value of a target cell by changing values in cells used to calculate the target cell. So let's imagine that this cell E14 is one that we want to change. We want a different answer. Now it's a formula that simply is subtracting two other cells, but those cells are getting their data from a lot of other cells. And ultimately, the cells that trigger big reactions in this particular worksheet are the ones we see in column B. So unlike goal seek, which does allow us to get a different answer based on one other cell changing, Solver allows us to come up with a different answer based on multiple cells changing. Let's go to the feature called Solver on the Data tab and the Analysis group. Here's the Solver dialog box. Set objective. We want to change the cell E14. Click or type E14. Set our objective to the value of 265,000. By changing which cells, now we could change the sales entry for January, the shipping entry, the goods, the freight, the miscellaneous, maybe all of them. Let's just change a few of them. I'm dragging across cells B5 and B6, and also I'm going to select B10. Now we want to allow these cells to change. But we do want to be realistic about it. So, let's choose Add. This means add constraints. The first constraint is that we want this cell B5, let's click on it, to be less than or equal to a certain amount. So let's imagine that we want to allow that January sales number to grow somewhat but not too far. How about 139,000? Now that might not be enough, we don't know that yet. Let's add another constraint. Let's allow our income from shipping, that's in B6, to grow a bit but certainly no more than 28,000. Let's add another constraint. And again, being somewhat optimistic, this time let's focus on goods, the cost of goods in B10. This time we want to allow that value to drop, but not too much, but we want to reverse the arrow here to say that that must be greater than or equal to 75,000. That's all the constraints we want. We'll click OK. Here we see the three constraints listed, two of those can grow but within a certain limits, one constraint but within a certain limit. We want this cell E14 to be equal to 265,000. Let's click Solve and we get a pop-up box. Solver found a solution. There certainly will be times where the message will say, Solver did not find the solution. And sometimes you'll see a number in the appropriate cell that's very close. The example here, we've got a total, and we've got a new number for sales. It's 137,687, a new number for shipping and a new number for cost of goods. And we've got our total here, so we've got a couple of options. We could restore the original values. We could keep these and return to Solver parameters dialog. If you're working with this and you decide to go back to original values, if you do want to experiment, you might want to make a copy of this worksheet before going here. But if you're fairly confident about what this feature can do or you've been told that it's a good one, you might just want to click OK, possibly keeping the results here. What I'm going to do for the moment is restore the original values and return to Solver parameters dialog box by clicking OK. So our numbers are back to what they were. What I didn't point out earlier and something you might want to look into, and this may involve some knowledge about Solver that I'm not familiar with. This is a very sophisticated feature and we didn't talk about the solving method. You might not be familiar with the terms GRG nonlinear, simplex LP. Each of these has a description here, and possibly as you make these choices, you might also want to explore options. And there are different choices here, different choices for nonlinear, different choices for evolutionary, mutation rate, population size, random seed. And so, familiarity with those terms will help you make different kinds of decisions about how to make this feature work for you. And if you want more advice, I'm simply going to close this here. It should have to go to the site www.solver.com. You'll get more information on this. This is a classic Excel add-in. It's been in Excel for any number of years, but this website gives you a lot of detail on how to make this work most efficiently. I think you can see from this small example. This is a sophisticated tool that allows us to do a considerable amount of financial analysis.